All right, what's up, guys? We are back with another session of lead coding. I'm so fucking done with lead code. Man, I can't give up this early in the journey. It's gonna take me at least 3 months. So, right, if I switch to just a second, I'll show you my screen. And right, look at this. Get a look at this. So there's 164 topics that I've already done, and there's 455. Simple maths will tell you 165, right? Or more. 164 less. There's 291 topics left. 291 topics, and right, 291 topics. If I do 3 topics every day, that's my current goal because I don't want to overwhelm myself. It's gonna take me 97 days of fucking elite code until I go through the entire thing. But once I am through all of this, that means I'll have done all of the patterns once, just once, which is not enough at all. No, it's not gonna stay in your mind if you do it once. I don't think it is. But well, I mean, what else am I gonna do, right? 3 months from now, or it's almost May. So it's complete May, June, July, and by August of 2025, I'll be somewhat familiar with all data structures of lead code, and maybe I can solve the problem of the day every single day after that. Ugh. This shit gets tiring, but no, it does not. I can't keep saying that to myself. This needs to change because if I just keep saying it gets tiring and I'm tired and this and that and yada yada, no, I- I'll just get fed up quickly. So let's not complain and start grinding out today's session. I'll just, yeah, get this out, send it over to my other screen. That's fine. Pop the chat out, put it against this, and we are almost ready for the stream. Right. Uh-huh, uh-huh. Okay. Well, I already opened the question. Right, so from where we left off yesterday, uh, just a second. Where we left off yesterday, right? We were doing these, and well, there's questions from recursion left and bit manipulation. And I watched a video about heaps for some reason. I'm just fiddling around, fiddling around. I get that. At least I have the freedom to fiddle around, I think, inside the sheet. Do you also do Rapido on the side? Depends. I've got a premium Rapido only for my friends, but I can't right now because Tanishq has my scooty, so you'll have to call that guy, and he never picks up when you need him. So luck is not on your side, friend. Right. So should do a recursion? Yeah, I'm gonna do a recursion question. Palindrome partitioning. I want to do at least one question from the stacks too because I want to start getting into a new topic. So given a string S, partition S such that every substring of the partition, every substring of partition is a palindrome. Return all possible palindrome partitioning of S. I know of a solution, but it's very not optimal. Uh-huh. All right. always putting myself above you, feeling gone. Well, the solution from the top of my head is I'm trying to enunciate more, move my lips around because I've noticed that uh, good for stream. Obviously it is, but uh, I've noticed I eat through a lot of my words, and I'm trying to change that over time. The stream's gonna help me do that too. Right. So an obvious solution that I think is you've got a string, right? I don't know, A, B, B, I don't care. You go through all of the substrings that it can form, right? All of them. And for each substring, you check, oh, someone's sending me hearts. How nice. I'm gonna send myself these. There's that you. How many concurrent viewers do we have right now? It's probably there. Yeah, it's just there. Man, I can find out who's. All right, so for each substring that you generate, just put a simple check on it. Is it a palindrome? If it is, then it's an answer. Like, yeah, two. So it's someone else. Interesting. Uh, and if it's not, then you don't add it. So I'm gonna create a function that checks if a string is palindrome. Private function for the class. Bool is pally string str. Uh, I did stop and they were still there, so we have another silent viewer. We just might for int I equal to, well, it starts from the first index, I is less than str dot length divided by 2 and I plus plus. That's a basic two-pointer solution that I'm going for. If stri is not equal to str uh, str dot length minus I. Well, I'm just gonna find this once. Int ln equal to str dot length. I don't want to keep typing it over again and again. Replace this over here. Length is equal. If it's a 5 then divided by 2, that's 2. Yeah, that works. Minus I minus 1. Len minus I minus 1. Then return false, else you return true. Right, this is just a simple, oh God, a simple two-pointer solution. So 1 points here, 1 points here. We check if this is equal. If they are, then we move this here. Over. Move these here, and we move these here. We check if these are equal. They're not. Well, then it returns false. If they're still equal, then it returns true. Anyways, we're done with that. And then we're gonna create a void helper function because we need to add all the substrings. We've got a vector string that's gonna be passed by reference called ans. The string itself, obviously, an index, and pass this by reference to string current that tracks where we are. Create a vector string answer, create a string current that's empty, call the helper function with answer s Index starts with 0, curve, and then return the answer. Just a second. Uh, so return the answer. The helper function takes a base case, which is going to be, well, if index is equal to s dot length, that's the base case. If is pally curve, then answer dot pushback current, else you just return without doing anything. And then you're gonna either choose the current one or we're not gonna choose the current one. So if you do choose the current one, then that's helper called with answer s index plus 1 and curve plus s of index. If you don't choose it, then wait, then you just remove this, and that should be our answer. Palindrome partitioning. Answer dot pushback curve. No matching one member for this. A vector of every substring of the partition is parallel, return all possible. It's a vector of vectors. Uh-huh. Why is it like that? Why would you do that? Partition S such that every substring of the partition every substring of the partition is a palindrome. S, you partition S such that every substring of the partition is a palindrome. Holy fuck, wait. Uh-huh. So this right here, this function gives us a list of all the palindromes. And now we need to create partitions of S. So we need to divide a string A, B, B into partition. So this is a partition, right? Or maybe this is a partition. This is also partition. But every substring of this, every single substring of this should be a palindrome. How the and we generate all the substrings. I need to. Okay, this is gonna take. This is a different twist. I need to generate all partitions of S. How do I generate all partitions of S? This is gonna exist, that I know for sure. Right. Generate all partitions of S. So we're gonna start at this index. So this is the start and this is the end for now. Start goes from this to this and goes from this to this, right? Start is a for loop, end is a for loop inside start, and right, let me try that. I need more test cases to see if my understanding of the question is correct. Return ANS for now, just so I can test. All right, so it's A, B, B, C, A, B, B, C. Why is it in different vectors? Why is it in different vectors? That's not okay. Why is A being repeated? What? Contiguous non-empty sequence of characters in a string. By substring, you mean it should be a contiguous non-empty sequence of characters. No, I don't understand this question. These are being repeated. Why are they being repeated? So it's A, B, A, B is being repeated here. Partition S such that way to partition S is in the way to. Okay, so this is a way to partition S. This is another way to partition S so that each substring. Now I got the question. But in the worst case, the letter itself is always a palindrome, right? The letter itself is always a palindrome. 1 by 2 0, and it's just going to return true. Right. So we start with a string and then create partitions. Right. A, B, C. We pass it into a function. And then max partition length is 1. Always putting myself above you, feel important. No one such that each substring and it should be contiguous. Substring is a contiguous non-empty. Did you finish the ball, pop, and push question? I did. I did. We're gonna do another one of those, like from this of a similar sort. Sorry, I didn't look at your chat for a long time. I had trouble understanding the question. It's a completely different ball game. Right. Check substring. Hmm. So this is gonna go through each. What does this do? Oh, what? No, I do get BCB. And for BCCB, very. Oh God, I can't understand the question. A, B, BCB. I don't know. I need a video on this.
Stop wasting time applying for jobs on LinkedIn or Naukri or other online job portals. You know why?
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem palindrome partitioning from the SD sheet. But before we move on to the problem, if you guys are new to our channel, please. Now you know what is a palindrome string, right? A palindrome string is a string that reads the same backward as well as forward. So if you take this example where S is given as AAB, so you can say that you can have two kind of partitions where you can have one of the partitions as A, B, while the other partition can be A, and B. So you'll get this string. So you can see that the size of the string can at maximum be 16. So that actually gives you an idea that you can write the brute force of generating all the partitions. So let's take this string. So if you take this string, the possible answers can be, you can decide to have a partition here, then a partition here, then another partition here. So if you decide to have these kind of partitions, you will end up getting the string a a b b. So this can be the first partition, and the other partition can be, you just decide that you are gonna have a partition over here and then over here and nothing else. So this will give you a and b. Now suddenly you can also think of having the partition over here b. Now all of these substrates in themselves. Other partition that you can try to do is, you just put a single partition over here, all the other partitions, and you'll only get these four partitions as your possible answer. So this is what the problem states. So this is the first list of all the substrings, this is the second list of all the substrings, this is the third list, where this is the fourth list, and your task is to return a list of all of these lists that are possible. Since an string has to be a palindrome, and the we are doing a partition, every substring has to be a palindrome, and the partition can be anywhere. So it's basically, you have to write a function that does the same thing again and again. And you know, whenever you write a function that does the same thing again and again of partitioning strings, that is when you start thinking of recursion. So how will you think of recursion? So what is your task? What is your primary task? The primary task is to partition. Okay, so let's do it step by step. So what if I ask you, which is the first position where you will partition in order to get a substring, that is palindrome? Your answer to that will be, you'll try partitioning over here. Yes. So if you do a partition over here, you will still be left out with a substring ABB. But since you've partitioned here, this string, this substring is a palindrome. So that's your first thinking. Where can I have the first partition? That's over here. Now, what if I ask you, if I don't allow you to have a partition here, then where can you have your second partition? Now, the answer to that will be, you can have your second partition over here, right after A, you can do a partition. Why? Because this double A is a palindromic substring. So if you do that, you'll be still left out with a string BB for which you have to do a partition. So can you do a partition over here? The answer to that will be no, because if you do a partition over here, this substring in itself is not a palindrome, and what you require is whenever you do a partition, the substring should be palindrome, so thereby you cannot do a partition here. Can you do a partition here? Obviously not. Why? Because AABB is not a palindromic substring, so we cannot do a partition here. So we can see whenever we started, we could only do a partition over here and a partition over here. So that is what we do. We try to do a partition wherever it is possible. So when we have done a partition here, we are left out with this string. So let's call a recursion for this string only, that's ABB. So now if I ask you, where can you do a partition in this ABB? Your answer to that will be, you probably can do a partition right over here. Yes, right over here. And that will give you something like this. If you do a partition here, this substring in itself is a palindromic substring. So you'll be left out with a substring BB. Now what if I ask you, what is the next index where you can do the partition? Can you do a partition over here? Can you do? No, because this substring then will not be a palindromic one. Can you do a partition over here? Again, no, because this entire substring will not be a palindrome. So the only partition you can do will be over here, and you do that. And after that, you tend to call the recursion for the remaining substring, that is BB. Now my question to you is, where can you do a partition? Can you do a partition here? Yes, you can do it. So if you try to do a partition there, what you get is A. Right after that, you do a partition here. So this substring in itself is a palindromic substring. After that, you are left out with the substring B. For that, you again call a recursion. Remember, now since you did a partition here, my question to you is, can you do a partition right here? Yes, you can do that partition. And if you do that, what you'll get is A, and since you did the partition at the end, you will get B, B. Now this is a substring in itself. Now since you were able to do the partitions in such a way that at the end, you put a partition at the end. So that is where you stop. But let's wait. Let's do the left part first. Where's the last partition that you did? Right. Now this is a substring in itself. Now since you were able to do the partitions in such a way that at the end, you put a partition at the end. So that is where you stop. But let's wait. Let's do the left part. First, where's the last partition that you did? Right over here, and you're still left with this substring. So let's call a recursion for this substring. Now, when you call a recursion for this substring, it decides where to do the partition. So can you do a partition here? Yes, you can do that partition, because if you decide to do that partition, you will be again doing a partition at the end, and that will make sure that this substring is a palindrome. And since you're able to do a partition at the end, that means this substring, this substring, this substring, and this substring, which is nothing but A, B, is a partition where every substring is a palindrome. So this, whenever you reach the end, remember, whenever you reach the end, your recursion call is over. So now it's time to get back. So that's backtracking. So make sure you get back. And whenever you get back, you can that this recursion call is also over. So you try to get back. Now this recursion call was left out because you always call the left recursions at first. So this recursion call was left. Whenever you call this recursion, a partition was done at the end. So whenever you do the partition at the end, what does that signify? That means you were able to partition in such a way that this A was a palindrome, this A was a palindrome, and this BB in itself was a palindrome. So you basically get another list of substrings or another partition where all the substrings are palindrome. So you can again store it in your list of substrings. So this recursion I can say is over. So it's time to get back. So I can say I was successfully able to do the partitions from here. So my job is done. So the recursion for this is now over. So I get back. So since I get back and I see that there are no possible other partitions apart from this, because you cannot partition here, you cannot partition here, because all the substrings will not be palindrome. So this recursion is also over. So you try to get back. Now since this left recursion call of partition is over, we come out and check for the right. So the right has a partition over here. So it calls a recursion for this now. So whenever you have this BB, where do you want to partition at first? The answer to that will be you'll try to partition here. Can you? Yes, you can, because if you do a partition, you will have right here B, and that's a palindrome. And you'll still be left out with a substring B, yes, for which you'll call a recursion. And the other partition that you can do is right here to execute the ABB partition. Looping. I'm looping and checking if a partition is possible. And if I was able to partition here, I basically doing a partition on the first. So make sure whenever you're trying to partition on the 0th index, please do check if 0 to 0 can be a palindrome, if 0 to 1 can be a palindrome. Similarly, there will be an index. If 0 1 was a palindrome, if 0 2 was a palindrome.
42 lakhs per annum.
Wow, 42 lakhs, that's your salary?
Yes.
And what do you do?
I'm an AI.
Palindrome. Show you the code and you'll start understanding it in a much better way. But this is the generalized version. And what is the base case? Whenever you reach the end. So whenever you reach the end, so that means whenever you reach the index as n, I can say whenever your index reaches n, that means you're able to partition everyone, and all these substrings would have been stored somewhere, and you can store them in your ultimate answer. So once you see the code, you will start getting a index 0, and the we do is we take that substring. Like if 0 0 means A, 0 1 means A, if that is palindrome, so we're taking A, right? We are taking A, right? So we store that in our list, which is the path. So ultimately A will be there. So that is what I'm doing. I'm storing it. And once you have done the partition at 0, that means if you have done the partition here, or if you have done the partition here, then we start from the next index, right? That's why I call I plus 1 and we
I'm so done, bro. Took me over almost an hour just for this single question. God, this is tough. I mean, I couldn't understand the question at first, and when I did, I understood it wrong, and then I watched the video to understand the question, and even after I did understand the question, because of my previous understanding, I got fucked, is what I'm trying to say. And these are supposed to be mediums. I haven't even gone to hards. My brain's gonna explode. Well, anyways, I'm not doing bit manipulation, bro. Wanna do some stacks. Let's do some stacks. Yeah, so implement stack by linked list. I open the question. Please reload the page. Let's give it a try. You have a linked list and must implement the functionalities push and pop of stack using this killer linked list. The task is to use a class as shown in the comments in the code editor and complete the functions push and pop to implement a stack. The push method takes one argument to be pushed in the stack. Pop, it returns an integer present at the top and popped out from the stack. If the stack is empty, return -1 from pop. The input is given in form of queries. There are two. One. Yeah. All right. So where's my, yeah, okay. There's the structure for the node. Right. Stack node star next. And stack node int a table to index equal to null. Stack node star top. Um, 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 um. Push pop. So I've got a linked list, right? Usually what you would do is you would point this to a new one. What I'm going to do is create a new linked list, create a new node and point it here and rename. So suppose this was T. I rename this new node to T. And I'll add another node. You take it, you make it point to this thing, and then you rename this to T. Now you pop this ahead. Now, yep, I think I got it. This was pretty fucking simple. But well, couple of data structures that you gotta use, so it's gonna be interesting. So stack node star node stack node x node next equal to so this is the address. This points to null now. And when I create, suppose you create two, so this two node is created, then 2's next points to this null, and then this the top is equal to 2, and then we'll create 3. 3's next is pointed to 2, right? And when we pop, well, num equal to top data, right? Stack node star temp equal to this top, this top, this top equal to this top next, and you delete temp, return none. Should work. This should work. Okay, it does. Submit it. Seg fault. Oh, right. This, if this top is equal to null, return -1. Yes, my bad. Gotta take care of the edge case. Yay, works. And this should be the most optimal solution. Is this the most way to create a stack using a linked list? Clean up this tag when it goes out of scope. Obviously, not do this time. Yeah, it's okay. Got it. At least this question was easy. Implement a queue using a linked list. Queue using a linked list. Try on GG practice. Another queue using another queue. A query queue is of two types. One, a query of this type means pushing into X into the queue. Query this means to pop an element from the queue and print the popped element. So a queue is first in, first out, right? So you create a new node. What's queue node star next? Data equal null. Switch of my queue node star front. Rear void push. Okay. This make it a new node. And front and rear point to the same thing. And then you want to create a new node, you just add it. And then rear point to this, points to this. And then you want a push and a pop, right? Queue is empty, returns -1. You want to push and a pop. Well, when you want to pop, front goes to the next. And you delete this now. Pop, front goes to the next. You gotta check if front and rear are equal. So pushing is pretty simple. You just create queue node star node new queue, pass in the data so a new node is created, and this if this front is equal to null. Just a second. uh all right, I'm back. Well, see, if this front is equal to null, that means the rear is also obviously null. Then this rear is equal to this front is equal to node, and regardless of any case, this rear will point to the node, right? Wait, so if it's null, then you just do this and then you return. If this front is not null, then this rear, that means the rear is not null either, right? So rear next is equal to node, and then this rear is equal to node. Right, that should handle all the pointers. This front is equal to node. Right, and then you just return the pop method. If front is equal to null, that is this front. That means there is nothing in here, so we're gonna return -1. So if this front is equal to this rear, well then this means q0 start temp equal to this front equal to this front is equal to null, this rear temp. It's called data, data. And if these are equal, then just get the temporary node. Treat these as rear. No, you need to pop the front element, right? So if the front is equal to null, you return -1. And num equal to this front data. Temp equal to this front. If this front is equal to this rear, then you set front as null. And you set this rear as null. And as this front equal to this front next, and then you delete temp, and then you turn the number, and it should work. Should work, should work, should work. It should work, it should work. Node equal to new, so node A. A was not declared in the scope. It's X. It's X. Yes, I'm proud of this solution. Please work. It did work. That's nice. Is this the most optimal to implement queue using a linked list? Correct and optimal. New and delete a free memory. Correct handling of edge cases. Constructor is empty. Destructor. Yep. All right. It's all correct. Check for balance parentheses. This is an easy question. I've already done this in the past, so. And I'm already on a very weird number, like 167. I'd like this to be 168 because then it's 455 minus 168, right? And that's divisible by 3. It's not 455 minus 167, 298. So it is divisible by 3. So I should not technically move forward. Man, fuck it. I'm done today. Ah, all right. I'm gonna do one of these. Then we can move on to prefix and fix postfix. Blah 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 yada. That's it for today's data structures stream. Spend an hour on that question. We also got to revise all these. I've got them saved up in a sheet. If you were seeing what I did, I just saved them all to a Google Sheet using an extension my friend made. So see you guys in a while or tomorrow because I've got some work from college I need to finish too. Probably gonna focus on that. Might even go to college tomorrow, so a late stream again. We'll see.